Assalamualaikum warahmatullahi wabarakatuh. My name is NURUL AQILAH binti Muhammad SHAFE'E and from group 2, and my lecturer is Dr. Mai, and the subject I am discuss about is linear algebra. So in this video I will explain two things, which is what is the Euclidean space and Euclidean inner product. So before we go to the explanation, I will brief you a little about who is this famous mathematicians that create these terms, which is Euclid. Yeah, that's him. Around 325 before century, Euclid was a Greek mathematician teachers at Alexandria, or we call as Iskandaria in Egypt. He also known as father of geometry. He is famous with his works, which is Euclid's Element of Geometry, and it became the second largest selling book after the Bible. You know, the Bible is the religious book that Christians believe about their worship and so on. Okay, I will stop talking about him and let's continue our discussion. So, Euclidean space in geometry is a 2 or 3 or 3-dimension space in which the axioms and the postulates of Euclidean geometry apply. I will tell you a little about the Euclid's geometry, which is the axioms and postulate. Okay, axiom is the assumption where based on the general mathematics and also not specifically based on the geometry. And meanwhile, the postulate is the assumption which are made strictly on the base on geometry. Let me take one example from the axioms, which is things which are equal to the same thing are also equal to one another. For example, is we have A equal to B and B equal to C. Then, if we look at this, it's the same thing. A equal to B and B equal to C. Then, A is actually equal to C also. Yes. Meanwhile, for the postulate, for the first example is between any 2 points, a line can always be drawn. Okay, let's say I have 5 points. Okay, you can see we can have ED points, EC, DB, DA. So we can draw a line between the 2 points. Okay. Ta-da! After you draw it and complete the all points and lines, you can see this star loop. The Euclidean space is not only for 2D or 3D, but it is also a space in any finite number of dimension in which points are designated by coordinates, and the distance between 2 points is given by a distance formula. So this is the distance formula that we have already learned in since the middle school. I mean the secondary school. Yes, this is for the 2D dimension. If we want the 3D, we have at the another point. Let's say E and F. So yes, we have to change the formula. We have to add. Okay. Okay, the Euclidean space we can denote as R the power of n. Okay, we now have two n tuple and n space. N tuple is something like if we have r equal to 3, then we let's say the vector is u. Okay, u1, u2, u3. Or we can say in the proper way is An ordered n tuple is the sequence of n real numbers. Let's say you okay like this lah. U1, U2, and U3, and if the two, if R n, maybe we can like this. Yes. From this, the set of all ordered n tuples is called n space. N is denoted by, yes, this is the basic, the main we want. Okay, when n equal to 1, which is the dimension is 1, we can call it as a line, like this. When n equal to, which is the dimension is 2D, then we can call it as a plane. Something like this, yes, plane. And the third one, we call this as a plane because we have a width and breadth. Meanwhile, L equal to 3 because we call it as a volume because we have the height. We also have this. And I'm sorry, when n equal to n, which is we don't know how many the numeric numbers. So when n equal to n, it's become a dimension. Many dimensions that we could not imagine. Okay, that's all from me for the Euclidean space. Now let's move on to the next question. Okay, let's move on to the next question, which is what is the Euclidean inner product? Okay, Euclidean, okay, by the definition, if the vector, we have the two vectors, which is u and v, and the component of u is u1, u2, and dot 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 un, and another one is v, the same, v1, v2, dot 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 vn. These two vectors in Rn. Then the Euclidean inner product u dot v, vector u dot vector v is defined by u dot v equal to u1 v1 plus u2 v2 plus dot 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 un vn. Okay, we can see that this pair is this and this, this and this. Note that when the Euclidean inner product is when the n is equal to 2 or 3, then the inner product is also called the dot product. Yes, dot product. And I forgot to say that why this is called inner, because when we dot this product, we can see that this is the component of the two vector, like u1, u2, and dot 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 un is the component of the vector u. So that's why we call it as the Euclidean inner product. Okay, for the example, let's say I have Euclidean space R2, and so we want to find the Euclidean inner product. So we will take the inner one, the component one. Yes, this is -1. Then we use the method, and we can 5 times 10 plus 6 times -1. So we get 50 minus 6, so 44. Okay, that's all for the Euclidean inner product. Okay, thank you for watching my videos, and I'm very sorry because I know I'm like in many ways, like pronunciation and explanation, and I hope it's helped you to understand. But if it has a mistakes or many mistake, you have to correct me. And thank you so much. Bye. Assalamualaikum.